Hey everyone, welcome back to my channel EduVibe. So today we will start with the another topic of 1D kinematics, which is the graphical analysis in uniform acceleration. So we will talking about the position time graph in my previous video where we will calculate the velocity. In today's video, we will focus on the acceleration. That when we have that type of graphs, which is the position time graph. So how can we calculate the acceleration? In the velocity time graph, we maximum of times we have that type of graph which is a uniform acceleration. Uniform means the straight line motion. So today's we'll focus more onto the graphical analysis with the uniform acceleration. So we will start with the position time graph. So it's the recall of the position time graph where we find the average velocity with the position time graph. But today we get the new aspect for this too. There's two ways to calculate the velocity when the velocity is changing throughout the motion. When the velocity is changing, we will talk about the straight line motion in the previous video. We will talk about the position time graph with the straight line motion. But in today's way, we will focus on position time graphs, but with the when velocity is changing throughout the motion. So first is the average velocity. So average velocity we will find when it's changing, when the velocity is changing at the maximum points. So we can calculate that average velocity with the slope of the secant line. So what is a secant line? So here you can see that we have a graph which like a curve graph. This is graph which is curved, and you will see that there's a 2 points over there which join together, and that the 2 points which join together they form the secant. When on the curve or on the circle we will touch to the 2 points, like in there we touch into 2 points, like this type of graphs we call as the secant. This is a secant. So that secant will get the average velocity. From that secant line we will get the average velocity. So like in this point, this point touches as t1 and this point touches as t2. So from t1 to t2 we get the secant, which we get the slope of secant line, and from here we get the average velocity too. Like from the point t is equal to t1, and from the point to the t is equal to t2, which is this. So from here we get the average velocity, and that average velocity will find when we have that 2 points. We will see the examples for this in later on. Next is the instantaneous velocity. So what is instantaneous velocity? So here we have main focus is for instantaneous velocity. So instantaneous velocity is the object's speed and direction. So it is the velocity, so we have the direction too. So the object speed and direction at one exact moment in time. So at the one exact moment of time, what is the speed and the direction for that particular object is that in instantaneous speed. So for instantaneous velocity, sorry, it's instantaneous velocity. So for the instantaneous velocity, like we have a position time graph over there, like at this point of time, we have that one exact point moment of time where we calculate the speed and the direction for this object. So here we touch with only 1 point. So on the curve or on the circle, when we touch on the only 1 point, so we get the tangent for anything. Like in this curve, we have that curve and we have that line passing through this only at the 1 point. So this is called the tangent. And from that point, if this is t is equal to 1, so we get the instantaneous velocity from there. So velocity is equal to when t is equal to some t1. So we have the example for this, as I told you. So we will focus on this example, but one thing in this, they only the reference for this that south is negative and the north is positive. So let's focus on this example. So how can we get the average velocity? We have to find the average velocity and the instantaneous velocity. So we have a particular time of interval for average velocity first, which is 0.25 seconds to 5.00. So firstly, we have to make something. We have to make the secant for this. So to find the secant, for the first one, we have to find the secant. So we have to touch to 2 points which are approximately like from like over there from 0.25, this is 0.25 and this is 5.00. We have to make one line straight to this. Let's take the scale and made that point which touch the graph exactly for 2 times. Made that graph like this. So here I made the secant. Here's 2 points where we meet them, like in that and in this. So this is the secant time graph. So if we have to find for A the average velocity, so it's the so we have a two type. We have a there is a 1 point and there is another point. So this point is approximately 50 at set, and this point is exactly at sits. So it's 50 and this is sits. So we have a like if we treat it as a displacement because the velocity is uh, displacement, or we can write because we know that d is a delta d upon delta t. For delta d, we firstly have 50 minus 6 upon, we know the time is from 5.00 seconds to 0.25 seconds. And when we find this, we get 9.26 meter per second. We need 2 gates for this. So we get 9.3 meter per second. So that's how you can find the average velocity from the secant slope. So now you have to find the instantaneous velocity at 110 seconds. So for this you have to first make that point on the graph, on that curve, that where that 1.0 seconds lies. It lies over there. Now you want to scale and put the line, put the tangent which passes through this. Like this. So we get the tangent which is at 1.00, and now we want like exact points on that tangent that where you get your instantaneous velocity. For instantaneous velocity, you want, so we find instant velocity. So for this we need y2 minus y1 upon s2 minus x1. So we want 2 points on that. So I take 2 points. Like first I take from here this point which I mark black, which is at 14, and is straight to the that point between 0 and 0.5. Next point I take, which is this point, which is over there at 36, and from here we get between 2 and 2.5. So now we have this point which is 0.25 and this point which is 2.25, and this is 14, this is 36. This point is your 0.25 comma 14, which is x1 and y1, and this point over there is 2.25 comma 36, which is s2 y2. So right over there you have to write y2 is 36 minus 14 upon 2.25 minus 0.25. To get the instantaneous velocity, we get 11 meter per second. So this is your answer for instantaneous velocity, and this is for the average velocity. So that's way you have to deal with that type of sums with the graphs. Next one we have the velocity time graphs. So in velocity time graphs, we have acceleration and displacement. For acceleration, acceleration is the slope of a position time graph. When we calculate that slope of the position time graph, so we get the acceleration. If the velocity time graph has a constant slope or the straight line, if the velocity time graph has like a straight line slope, then the object has a constant acceleration. So from there we tell that that graph has that object has the constant acceleration. Displacement has another aspect. Displacement is the area under velocity time graph. So if they tell about that, you have to find the displacement from 0 to 5.00 seconds. So you have to make like part, like there's a 0, there is a 5.0, so you have to make like this part. So this whole part is the displacement part from the velocity time graph. So you have to find the area for that part to find the displacement from 0 to 5.0 seconds. So a area between the line and the t-axis. T-axis is at the time axis. So from area between the line and t-axis, which you want from that, which range of time. So from here you get the displacement with that area of that particular time. So let's deal with this example. Firstly, we have to determine the object's acceleration. So to acceleration, we know there is the like straight line graph. So we want exact points from where we can calculate this. So here you have 14 like value, and from here you get the z value of 2, which is easy point to calculate. This point, and this 2 is 2 multiplied 10 raised to power 2 because it's mentioned over there. So this point is 14 comma 2 into 10 raised to power 2 meter per second, and this 14 is in seconds. Okay, so next point we will take, which is like I think this one, which is exactly at 31. So this 31 comma, which is in seconds, 1 into 10 raised to power 2 meter per second. So for the acceleration of this object, acceleration is a vector. So y2 minus y1 upon s2 minus x1. So this is your x1 y1. This is your x2 y2. So our y2 y1, which is 1 minus 2, and we will put 10 raised to power in common, and there we have 31 minus 14. So our acceleration is, when we do this, we get minus 0.0588 into 10 raised to power 2, which is when we shift that point over there, we get approx value of minus 6 meter per second square, and this was the answer. So this is the acceleration. We get a negative because it goes from like upwards to downwards. It goes from up to down. So that's why we will get that acceleration in negative. So we can take at any point which you have, like which are the z values, or you can take any value which are in operates. You can any value from the graph to calculate the acceleration. You get that 6 or 5.8 or like 6.2. That's all answers are okay for this. Next, you have to find a displacement from 9.0 seconds to 28.0 seconds. For this, I have to raise this, and we made the graph according to this. So here are 9.0 seconds, and the 28 is over there. So I have to put that line to get the specific space for this. So you get this. So this is not that, it is not type of a rectangle or triangle to find the area. So you have to like put that straight line over there. So you get the two parts of this. One is this, second is this. So first one is the triangle and second one is the rectangle. You get the area of triangle, which is half into base, we all know, and the area of rectangle, which is length into breadth. From here, when we get those, you get add them all to get the total displacement from 9.0 seconds to 28.0 seconds. So how can we deal? So we know that the for one, we know that our triangle area is half into base into height. So half. So what is the base for this? So base is like this. This is the base. Base is for triangle and rectangle is the same. So to calculate this, so we know that our here is 29, here is 9, here is 28. So we get the base from there, which is 28 minus 9 seconds. And you have to again into by the height. So height for triangle is from here to somewhere here. So to calculate the height, we have to know about this stuff. This is the height from the that point to that point. So what is that point? So here's 1. It's 1 into. So it's 1 into 10 raised to power 2, which is 100. So it's 100, 200, no, it's 1.5. So it's 100. So it's 110, and this is 120. So this is 120 right over there. This is 120 point, this one. And for this one, you again have 200 for this. This is 200. Then we have 210, and then we have 220 for this. So this is 220. So you do 220 minus 120. And now we have to do multiplication for this. So for that we get 950 into 10 raised to power 2 meters. Because this is into 10 raised to power 2. Then for second, we have to find the area of rectangle, which is length into breadth. For the breadth, you know, like this from 9 to 28. So it's 28 minus 9 seconds. And for the length is from 0 to 120. So 0 to 120 is 0 minus 120 is 120. So it's 120 into 10 raised to power 2. So to find it out, 2280 into 10 raised to power 2 meters. So now you want the total. So do the total for this. Do addition for both. You get 2166 into 10 raised to power 5 meters. So you get the approximately of this answer. So this answer also varies from your point of view to my point of view. So you can take any points, but the approximately values, you get the answer around this value. Not like exactly this one. You can try by your own to get that the answer for this. So here's for the graphical analysis. I know this is the part was like a tricky part. You have to know number of things to like approximately value, but don't take tension when the EduVibe is over there. If you need any extra questions for this, let me in the comment sections. I will make another video for this to get the more complex questions or the easy questions. which are important for the exam point of view. So learning made simple with EduVibe. Learn smarter but not harder. Please like, share, and subscribe to my channel. See you in the next lessons. Till then, stay connected with EduVibe.